Hello and welcome to my YouTube channel EDUWISE 101. For those of you who are new here, my name is Mr. Kandasamy. I am a science teacher with nearly 16 years of experience and a current examiner. In this video, I will be going through the June 2020 foundation paper for EDEXCEL Combined Sceince. I will walk through the exam questions, highlight the key points, write model answers with reference to marking schemes and the examiner's report where possible. Most importantly, I will show you how to turn past papers into a valuable resource filled with notes and illustrations. Let's begin in question 1. Question 1. Draw one line for each use of wave to the matching electromagnetic wave. Here they have given you two columns, use of wave and the electromagnetic wave. So as you can see, they have given three different uses. The fourth, they have already labeled it to gamma waves. So let's fill in the rest of them. So out of these three uses, the easiest is to detect broken bones. That would be the X-rays. The wave that is used to detect forged banknotes is ultraviolet, and the one that is used for night vision cameras is infrared or infrared waves. Now, as this is revision, I'm going to give you some extra notes. So let's write down some other uses of radio waves. So radio waves are generally used for communication. Microwaves are generally used for communication and cooking. Infrared is also used for communication. Communication in remotes. So remote controls use infrared waves. Visible light is what we use to see, and we use it for photography. So to see and used in photography. Ultraviolet, apart from being used to detect forged banknotes, it is used in sunbeds. So used in sunbeds. X-rays, we already know that it's used to detect broken bones. So gamma rays, apart from being used to sterilize medical equipment, it is used to cure cancer or kill cancer cells. Now let's move on to the next part of the question. Question 1b. Ultraviolet light has a higher frequency than infrared. Which of these colors of visible light has the highest frequencies? So they have given you 4 different colors. Now the answer is blue color. Now how do I know that it is blue color? Let me give you some notes for this. So here I have listed out all the EM waves, radio waves, microwaves, infrared, visible light, ultraviolet, X-ray and gamma. And under visible light, these are the different colors of light. So starting with red on this side, and then it ends up with violet. So we've got red, orange, yellow, green, blue, indigo and violet. Now as we move from one side of this list to the other, from radio waves to gamma, the wavelength is decreasing and the frequency is increasing. So blue has a higher frequency compared to the green, orange or yellow. Hence the answer was blue. Let's move on to the next part. Part C. Figure 1 shows how the brightness of a source of light changes with wavelength. So here you have a graph. On the graph here on the y-axis is the wavelength in nanometers. They have given you numbers starting at 360 and it ends at 460. So the wavelength is increasing as you go along the x-axis. Now on the y-axis they haven't given you numbers, but you can clearly see that the line is actually going up and then decreases. Now, so on the graph they have given you the values, which is 360 to 460. Now graph peaks at this point, which is about 410. So let's mark that on the graph, 410. Describe how the brightness changes with the wavelength. So how do you describe what is happening? As the wavelength increases, the brightness also increases up to a point and then decreases. That's going to be one mark, and then the second mark is for you to say the highest brightness is at 410 nanometers. So let's write the answer down. As wavelength increases, the brightness also increases and then decreases. The highest brightness is at 410 nanometers. This should give you both the marks because these 2 points is more than enough to give you those 2 points. Next question. That brings us to the end of question number 1. Now before I move on to question number 2, let me share you what the marking scheme says. So as you can see in the marking scheme, they have only drawn one line and we've got all of those right. And they've said if more than one line is drawn, then you lose a mark. Question 1b, the answer should be blue. And for 1c, you need to say that it increases and then decreases and it reaches peak. So if you include two of the following, then it'll be fine. And for us to say that it is the brightest at 410 nanometers, that should give you those 2 marks. Now let's move on to question number 2. Question number 2, which of these is the correct equation that relates force, mass, and acceleration? So F is for force, M is for mass, A is for acceleration. The correct equation would be force equals mass times acceleration. Now this is an equation that you should remember, and in the equation sheet this year they will give you this equation, so ideally you need to be able to find this equation. Question 2a, part 2, the cyclist has a mass of 70 kilograms. So they have given you the mass. Calculate the force. So you are supposed to calculate the force needed to accelerate the cyclist at 2 meters per second squared. State the unit. That gives you the second mark. So 1 mark for the force and 1 mark for the unit. So let's write the equation. We are going to use the same equation that we've identified on the top. So F equals ma. Mass was 70 multiplied by 2. That should give you 140 Newton. Right? So 140 capital N for Newton. You can also write the word Newton. You'll still get the mark. Question 2, part B. Another cyclist travels 1,200 meters in 80 seconds. Calculate the average speed of the cyclist. So the average speed equals the distance divided by the time. The distance they have given you is 1,200 divided by 80. This gives you a value of, let me bring in the calculator and show you how to do the calculation. So here's a calculator. 1,200 divided by 80 gives you an answer of 15. So that was 15. Let's move on to the next question. The student wants to measure the average speed of a cyclist. The student estimates, meaning that he's not actually measuring it. He thinks that one of his own steps is 1 meter. He counts 100 steps between 2 poles on a track. He uses a stopwatch to measure the time that cyclist takes to travel between the 2 posts. So in here we have the first post and the second post, and he's taken 100 steps between these 2 posts, and he's estimating that it is 100 meters between these 2 posts. State 2 improvements the student could make to this method. So let's write down 2 points. There's more than 2 points that you could actually make. So the first point I would make is use a measuring tape rather than estimating the distance between the 2 posts. Second point I would make is that because the student is standing here, he will not be able to see when the cyclist is passing the second post. So he can use a second student to signal the student when to stop the timer. So our second point is going to be have another person at second post to indicate when the cyclist passes. Another point that you can actually make is the student can stand between the 2 posts. So stand between the 2 posts rather than near the first post. This means if the student is standing between the 2 posts, that he can actually see when the cyclist is passing the first post and then the second post, rather than having a second person. The first 2 points is more than enough to give you the 2 marks. Now let's have a look at the marking scheme. Question 2a1, the answer was F equals ma. The value of the force was 140 Newton and capital N. The average speed to be calculated was 15 meters per second. And the 2 improvements: measure the distance using a measuring device. So they are asking you to give a suitable measuring device as well. And we said use 2 people in the timing rather than 1 person. You can use an electronic timer, add marks on the track, or stand midway between the posts. We've also said this as well. So any 2 of these points should give you those 2 marks. Let's move on to question number 3. This is question number 3. Question 3a. Figure 3 shows a symbol for the nucleus of an atom of strontium 90. So they have given you SR and 2 values here, 90 and 38. how many protons are in the nucleus of an atom of strontium-90? So they have given you 4 values. So how do you calculate the values of protons? Now these numbers mean something. So the bottom number and the top number mean something. So let's make a note of what they are. So this top number is the mass number made of neutrons and protons. So that's the mass number. And this bottom number is the proton number, or the number of electrons, also known as the atomic number. So how many protons are there? It's 38. So let me get rid of that and highlight the answer. The answer is 38. The next question, how many neutrons are in the nucleus of an atom of strontium? So in your test paper, if you have the test paper, you would make a note of this. So this is good revision. Remember, proton number, atomic structure comes up in chemistry as well. So going back to question 3.2, how many neutrons are there in the nucleus? So the mass number, remember, is made up of protons and neutrons. So mass equals the protons plus the neutrons. So if the mass is 90 and the number of protons is 38, the neutrons can be found by taking away 38 from the mass number. So what is 90 minus 38? Let's bring the calculator. 90 minus 38. It's always good to check with the calculator, so because you don't want to lose out that 1 mark. So the answer is 52. So let's mark that as the answer, which is 52, and get rid of the calculator now. And moving on to the next question. Question part B, the half-life of strontium is 29 years. So they have given you 29 years as the half-life. You need to know what the definition for half-life is. So let's make a note of this. Note, the half-life is the time taken for half the unstable nuclei in a sample of radioactive isotope to decay. So that's your definition for half-life. How do you work out the mass? So you're starting off with 1600. So after one half-life, which is 29 years, so that's your first half-life, the mass would have halved, which is 800. And then after the second half-life, it has gone down to 400. So the time would have actually doubled. So 29 times 2 gives you 58 years. So the answer is 58. Moving on to the next question. Part C, a teacher sets up an experiment to show some students how far beta particles travel in air. Remember, beta particles are fast moving electrons. State the scientific name for the radioactivity detector. We can call it a GM tube. Now GM stands for Geiger-Müller. You don't have to remember the full word for it. You just remember it as GM tube. It's much easier. Next question. The teacher also has a radioactive source that emits only beta particles. So as a source that emits only beta particles, a meter ruler as well. State 2 precautions the teacher must take to protect herself from the effects of radioactivity. So they're only asking for 2 precautions. So there's a number of precautions that you would do. Now, one of them is to wear gloves or use tongs instead of handling it yourself. So wear gloves while handling the source or use tongs. So wear gloves using, let's try that again. So there's a number of safety precautions that you would take. The first one I'm going to say is keep a safe distance from the source. Next one, use a shielding where possible. Fourth, wear gloves or tongs while handling the source. Any of those 3 should give you, any of those 2 should give you those 2 marks. Now there's a number of other precautions as well. When we look through the marking scheme, I'll discuss those. Next question, describe how the teacher could show how far beta particles travel in the air. Now, going back to this question, how can they use the GM tube to show that how far the beta particles are traveling through the air? So I will draw a very simple setup to show how this can be done. So let's say they have the source there and you have the GM counter here. So if the beta particles are coming from this, you want to measure how far it can actually reach the maximum. So what you want is actually the ruler in between. So how would you actually measure it? First, you would actually put the GM tube at the start and then slowly move the GM tube away from the source till you get a reading of 0 or to a minimum value that you're always getting. So without any source, you will also get some reading. That's what you call background radiation. So the first step is to measure the background radiation without any source. Now, if you don't mention the background radiation, you lose a mark. So I'm going to start off with by saying that. So first point, measure the background radiation using the GM counter without the source. Second point, keep the source at one end of the ruler. Third point, keep the GM tube in front of the source and record the radiation level. Next, slowly move the GM counter away from the source till the reading in the counter is the same as the background radiation. So slowly move the GM counter away from the source till the reading in the counter is the same as the background radiation. So these 4 points should give you the 4 marks. Now let's have a look at the marking scheme to find out what the marking scheme is saying. So for A1, the answer was 38, and 3A2, the answer was 52, and the answer here was 858, and we got those two right. And scrolling down, we can call it a GM tube or GM counter. There's all of the Geiger counter, GM counter is fine, but GM tube is fine as well. 3C2, keep a safe distance. This is what we said. Point the source away from the people. Handle source with tongs or at a distance. Again, this is something that we also said. Use gloves, or you can use shielding. We mentioned all 4 of them. We combine gloves or tongs into one. We'll still get those 2 marks. Question 3D. Question 4. Figure 6 shows a large tank of water. The tank of water is used to study water waves. Water waves are transverse waves. Give another example. Let's get out of that. So if these are transverse waves, give another example of transverse waves. Now, this could be any electromagnetic waves. So there are 7 different electromagnetic waves. So I'm going to list all of them so you can write down any of these. So starting with radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, gamma. Any of these will actually give you a mark. You can also mention other ways, but it's much easier to remember any of the electromagnetic waves. If you simply say EM waves, I doubt that you'll get a mark because they're asking for a specific example. Next part, figure 7 shows a side view of the part of the tank. A water wave is moving from L to M. So it's moving from L to M. Calculate the wavelength of the wave. How do you calculate the wavelength? So for that, you need to know the definition of a wavelength. So the definition of a wavelength is the distance or the length of one wave. Is the distance or the length of one wave. So that's what a wavelength is. So how do you work out the wavelength from this diagram? Remember, one wave looks like that. So it's the distance from start to finish. It's from there to there. Now, here you can also measure the wavelength from peak to peak. So that's your peak of the wave, and that's another peak, and then so from there to there, it's your first wave, second, third, fourth, 5, 6, 7, 8, 9, 10. So there's 10 waves between L and M. So to find the wavelength of just one wave, you would divide 32 divided by 10. That should give you 3.2 meters. Now, while we are here, you can also define the amplitude. So let's make some small notes here. So the height of the wave is the amplitude, and make a note of the definition for frequency as well. Moving on to the next question. A technician stands at the side of the tank. He counts the peaks of the wave as they pass him. 12 peaks pass the technician in a time of 15 seconds. Calculate the frequency. Now, the definition for a frequency is the number of waves per second. So based on that definition, if you are getting 12 peaks in 15 seconds, in order to find the time it takes for one wave, you would divide this 12 divided by 15. So what is 12 divided by 15? 12 divided by 15 should give you 4 or 5. To get rid, change it into decimals, you would press this button, SD. So 0.8. So the answer is 0.8 hertz. Next question. Figure 8 shows part of the inside of the Earth below the surface. So that's your Earth's surface. An earthquake starts at Q. So it's starting in Q. A seismic wave travels from S, Q to S. So it's going from here to there. A seismic wave is a longitudinal wave. Draw arrows on figure 8 to show how the rock at R, how this rock here moves when a seismic wave passes through R. So longitudinal waves, how you need to know how the particles move in a longitudinal wave. So particles vibrate parallel to the wave direction. So if the particles are vibrating parallel to the wave direction, the wave is moving from Q to S. So draw arrows on figure 8 to show how the rock moves when the seismic wave passes through R. So for 2 marks, you need to show how the particle is actually moving. So it's moving parallel to that wave. So, and it's vibrating. So it's not moving entirely in that direction. It's basically vibrating back and forth. So again, that gives you those 2 marks to indicate that it's actually along this line and it's going back and forth. And just to be safe, I would actually draw an arrow parallel to that and indicate wave direction. Now, because they're talking about longitudinal waves, remember there is transverse waves as well, right? In transverse waves, the particles vibrate perpendicular to the wave direction. So these are your notes, additional information that you could write down as part of your revision. Next question. The frequency of the seismic wave is 12 Hertz. So they have given you the frequency as 12 Hertz. The wave speed of the seismic wave is 7 kilometers per second. Calculate the wavelength. So how do you work out the wavelength? They have given you the equation wavelength equals wave speed divided by the frequency, and they want the wavelength in meters. Now, the reason it's 3 marks is because the wave speed that they have given is in kilometers per second. So you need to convert that. And now 7 kilometers in 1 second is the same thing. If you convert 7 kilometers to meters, you would multiply that by 1000. That gives you 7,000 meters per second. So you can use that value. 7,000 divided by 12. 7,000 divided by 12 gives you 583.3. 583.3 meters. Now, if you didn't do this conversion of 7 kilometers to 7,000 meters, you'll only get 2 marks for failing to do the conversion. Next question. A technician measured the frequency of the water wave in part A by counting how many waves passed him in 15 seconds. Explain why this would not be a suitable method for measuring the frequency of the seismic wave in part B. So what they're comparing is to the experiment that was done with water waves. Now remember that seismic waves are waves produced during an earthquake, right? So you cannot see earthquakes. You can feel them, but you cannot see them. But water waves is much easier to see and count it. So you cannot actually see the earthquakes. That's your first problem. The second problem is the frequency. Now the frequency of these waves, they've said, is 12 Hertz, meaning that there is 12 waves in 1 second. It's impossible to count how many waves or 12 waves in 1 second for a person. So let's write those 2 points. Question 4, any one from any of these, we listed all of this, and they've also said seismic waves. Do not credit for sound. They haven't mentioned it, or they've said EM or electromagnetic waves. So if you say electromagnetic waves, you still get a mark. The next part, 32 waves divided by 10, which give you 3.2 meters, which we got. And to find out the frequency, it was 0.8 for A3. Next question. And to draw the arrow for R. So this is what we actually did in our answer. By drawing this, you get 2 marks. So 2 arrows in opposite directions. So don't worry about this. You just need to focus on thinking how the particles are moving. For a longitudinal wave, it will be parallel to the wave direction. And for B, the answer was, we wrote it down as 583.3. That will give you those 3 marks, right? And if you wrote it as 5.8 because you failed to convert this kilometers per second to 7,000 meters per second, you would only get 2 marks. So we rounded up to 580. We should get 3 marks. Next question, an explanation to include 2. Waves cannot be seen. We've actually said that as well. Person will need another way of detecting. We didn't mention that, as person cannot count 12 waves, right? And we've said the frequency is too high. We should get those 2 marks. Now let's move on to question 5. Question number 5. A student lifts a toy car from the bench and places the toy car at the top of a slope as shown in figure 9. Describe an energy transfer that occurs when the student lifts the toy car from the bench and places the toy car at the top of the slope. So imagine the toy car starting being here. So that's where the toy car is initially. Now that is being lifted from there to there. What the question is asking is, what is the energy transfer when the student lifts the toy car from the bench and places the toy car at the top of the slope? So it's nothing to do with energy transfer here. Most students make the common mistake of actually describing what is actually happening here. So here the toy car has GPE. There's no GPE here. So what type of energy is actually being transferred here? So when it's being moved from there to there, yes, there is KE, but that kinetic energy is coming from the student. So the energy of the student is chemical energy. Remember, muscles have chemical energy. So your answer needs to start off by saying chemical energy to finally to GPE. So the answer that you would write is chemical energy of the muscles to gravitational potential energy. So to identify the chemical energy and the gravitational potential energy, you get 1 mark. And to say that it's actually moving from chemical energy to gravitational potential energy, then you get the 2nd mark. Part B, the student lets the toy car roll down the slope. Describe how the student could find, by experiment, the speed of the car at the bottom of the slope. So how are you going to find the speed? Now, the easiest is actually start off by saying speed equals distance divided by the time. So the equation for speed equals distance divided by time. Then you need to describe how you're going to find the distance and then the time. And writing all of this in detail is going to give you the 4th mark. So this is 1 mark, remember. So the next point I'm going to say is measure the distance of the slope using a measuring tape. Measure the distance of the slope using a measuring tape or ruler. The next point is to describe how we are measuring the time. So measure the time taken for the car to reach the bottom of the slope using a timer. So this should give you the 4 marks. You could also measure or you could use a light gate instead of a timer. So let me add that bit, or a light gate. Next question. The student needs to develop the experiment to determine the loss in potential energy and the gain in kinetic energy. Now, when they are referring to loss in potential energy, they are referring to the GPE. Now, remember, GPE equals the mass, gravity, and the height or gravitational field strength. And the kinetic energy equals half mass and velocity squared. Now, state the other measurement the student should make. If he wants to determine the loss in the gravitational potential energy and the gain in kinetic energy, he needs to work out the mass. So the first point is to say mass of the car, and the next point, in order to find the GPE, you have to work out the height. Remember, the height I'm referring to is the height of the slope. So vertical height of the slope. Now the reason I'm saying vertical height is, it's your notes. So I'm going to draw the diagram again. You're referring to this height. If you want to calculate the GPE here, you need to work out the height that the car has been lifted by, multiply that by the gravitational field strength and the mass of the toy car. Part D, when the toy car rolls down the slope, some energy is transferred to the surroundings as thermal energy. State how the student could calculate the amount of energy transferred to the surroundings. Okay, what they're asking is state how the student could calculate the amount of energy transferred to the surroundings. So here what they're saying is, when the toy car rolls down the slope, some energy is transferred to the surroundings as thermal energy. Going back to the diagram again, GPE, the car has some form of energy, gravitational potential energy here. Now, when it rolls down, it's losing a little bit of energy, and what it has here is kinetic energy. And what they're asking is, how do you find that? So the best way to describe this is to say original GP at the top. You don't really have to say original, or GP at the top minus KE at the bottom. If you take away the KE from the GP, then you should work out the difference, which should be equal to the amount of energy transferred to the surroundings. Next question. Explain one way. So when they ask you to explain, you need to give a reason. Explain one way the student could reduce the amount of thermal energy transferred to the surroundings as the toy car rolls down the slope. So how are you going to reduce this loss in thermal energy? First point, add oil or lubrication to the wheels. So by adding oil, what are you actually trying to achieve here? So you would say, to reduce the friction, that's it. And for 2 marks, you need to say you're going to add oil or lubrication to the wheels. So here you're implying that you're adding it to the axle, not to the bottom, the tire itself. And why are we doing this? To reduce the friction so that we don't lose any energy. Now let's have a look at the marking scheme. As you can see here, they're asking you to find mentioned relevant energy stores such as GPE or chemical, and the correct context is basically to identify the direction. 5B, measure of relevant distance, measure of relevant time, use of speed, and the detail. So you can say next question. So what are you going to measure? The vertical height of the slope and the mass of the toy car. And to work out the difference, GP minus KE at the bottom. And 5E, add lubrication or oil to the wheels. Why? To reduce the friction. Now you can pause the video and have a look at the additional guidance. I am not going through the additional guidance, but there are different answers that can be accepted as well. So pause the video and have a look at what are the types of answers you can actually write for the same marks. Let's move on to the next question. Question number 6. Which of these is a vector quantity? So they're asking you to identify the vector quantity out of these 4. The answer is force. Now you can make a note of what is vector quantities, and while we are at it, we can make note of what a scalar quantities as well. Vector quantities have size and direction. Scalar quantities have direction only. So vector quantity would be just the force. Energy, mass, and work are scalar quantities. Part B, state the equation that relates acceleration to change in velocity and time taken. So the equation that links acceleration, change in velocity, and time taken is acceleration, change in velocity, time. Next question. A van accelerates from a velocity of 2 meters per second to a velocity of 20 in 12 seconds. Calculate the acceleration. So acceleration is equal to the change in velocity. So it's going from 20 to 2. So you need to take away 2 from 20 and divide that by 12 seconds. That gives you 18 divided by 12, which is 1.5. Next question. Figure 10 is a velocity time graph for 15 seconds of a cyclist's journey. So from 0 to 15, it's a straight line. Now when it's a straight line, it's constant velocity. Calculate the distance the cyclist travels in 15 seconds. So they're asking you to calculate the distance. How do you calculate the distance traveled? Now in a velocity time graph, the distance traveled is equal to the area under the graph. So in order to find the area, this would be the triangle. So you're finding the area under the graph. So distance equals area under graph. So how do we find the area of a triangle? Is the length times the height divided by 2. So 15 multiplied by the height is 7 and then divided by 2. So 15 multiplied by 7, find the answer for that, which is 105. Then divide that by 2, which should give you an answer of 52.5. So 52.5 meters, 52.5 5 meters. Next question. Next question. Many factors can affect the stopping distance of a car. Some of these factors involve the driver and some of these factors involve the road. Explain how the stopping distance of a car is affected by factors involving the driver and then factors involving the car. You should include examples in your explanation. So we can break down this answer into two things because they've already given you 2 points. Factors involving the driver first of all, and then the factors involving the car. So though the factors that affect the stopping distance of the factors that involve the driver which affect the stopping distance is to do with the driver status, right? Remember, stopping distance is equal to the thinking distance plus the braking distance. So the thinking distance is what is affected by the driver and the braking distance is what's affected by the car. So let me write down the answer and then we'll go through it. Question 6, part D. Many factors can affect the stopping distance of a car. Some of these factors involve the driver and some of these factors involve the car or the road. Explain how the stopping distance of a car is affected by factors involving the driver and then factors involving the car or the road. So first point you have to remember is that the stopping distance depends on the thinking distance plus the braking distance. Now the thinking distance is to do with the driver. Now the braking distance is to do with the car and the road. Now you have to say what happens to the overall stopping distance as well. So let me write the answer and I'll walk you through how you can answer this question. Factors involving the driver. The reaction time of the driver, tiredness, being on drugs, the type of footwear, and how hard the driver presses the brake pedals all affect the thinking distance. So I've broken down the answer into different sections. First of all, I mentioned that stopping distance equals the thinking distance plus the braking distance. And under factors involving the driver, the reaction time of the driver, tiredness, being on drugs, the type of footwear, and how hard the driver presses the brake pedals all increase the thinking distance. So this increases the stopping distance. Now the factors that involving the car, poor brakes or worn out tires have less friction, so this can increase the braking distance. Let me change the spelling mistake. There you go. Muddy, wet roads also increases the braking distance. If the car is heavy, then this can also increase the braking distance. So overall, increasing the thinking distance or the braking distance will increase the stopping distance. We are linking it to the equation that we said. That brings us to the end of the paper. Let me quickly go through the marking scheme. Question 6. A was force, which was the vector, and the equation's acceleration equals change in velocity divided by the time. And 6b2, the answer was 1.5 meters per second squared, and the distance traveled according to the graph is 52.5 meters by finding the area under the graph. And for the 6-mark question, they have separated out factors concerning the driver, and we have mentioned all of these and what it actually happens, what happens to the stopping distance, and the factors concerning the car or the road. We mentioned all of these as well, and then again they are asking you to link to what happens to the stopping distance. So we have mentioned all of this. So our answer should give you 6 marks. Thank you for watching the video. If you think this was useful, hit the like button and subscribe to my channel. Hopefully I should be able to add some more videos to help you with your GCSE revision. Thanks for watching again. See you soon.